Okay. All right, Dmitry, do you want to share your screen for this, for sharing a bit about the history of Carvel tools?
Yeah, I brought just a couple of pictures just to make it a little bit more entertaining.
Awesome. All right, take it away.
I was afraid you were going to say slides.
Boom, slides. Tricked you there. No, it's just funny enough. I don't think I have any other picture creation software aside from the PowerPoint or whatever, the Google. What is it called? Google presentation or something. Anyway, we have some friends from Twilio on the call, and one thing that they've asked recently is, can we provide a little bit more historical kind of a context into some of this tool creation, and maybe how that also influences maybe some of the future ideas and whatnot. So I just kind of wanted to spend a little bit of time, and obviously this is interactive, so anybody jump in and add, ask questions, comments, whatever. But yeah, so let's kind of dive into it a little bit. And excuse my cough, still recovering here. So Carvel has started kind of organically, if one might say. I've been working on various configuration management, infrastructure management, container management solutions for a long time. And so over the years, certain ideas, they kind of form and, get refined, polished maybe. Certain ideas obviously quickly die, or slowly maybe even die if they don't make much sense. And so a lot of that kind of an initial inspiration for Carvel came out of this type of experiences, right? Working with real production environments, working with real users with their production environments, working with just different types of organizations and different types of users, because organizations may also influence how you build your software and how you actually manage your software. And so this kind of a, I don't know, pile of factors led me on a road of trying to think about this different concrete problems that we were encountering into various places, right? And so you will notice that Carvel is really fairly decomposed. It's not a monolithic tool. I worked on projects that were built in a very monolithic way, and there's definitely benefits to such tools. There's obviously downsides that come with such design decisions. And so it was kind of an interesting design kind of a journey to take in. How do you actually decompose some of these different processes into smaller, maybe simpler, a little bit more focused tools, right? And so to make it a little bit shorter here, Carvel started out with, I believe, first tool was KWT, which is actually not in any way really mentioned on the website, I think, or maybe it is one of the experimental boxes, and it still kind of continues to be experiment. This was actually a little a little journey that I was taking to just play around with networking. How do you actually bridge the network on the cluster? How do you bridge it to your local computer? And this is something that's been, for example, done by some of the other tools out there. There's a little section about that in GitHub. But while playing with all that stuff, I was deploying all kinds of resources or workloads to Kubernetes. One of them was Knative, I think. Another one was Cert Manager, and a few other things like Istio and things like that. And I've come to, from my previous experience, like certain, aspects of how do you actually converge a system, right? Been working with declarative systems for some time. And so there was a kind of a bar of experience that I was seeking, but I wasn't really getting, right? And obviously, we have tools like kubectl and a few other tools that help you do it. But I was trying to see if we can iterate on that experience and make that, make that experience a little bit more transparent. I've always had the challenge trusting tools, especially in the production environment at 2 a.m. What will it do? And so, there's all kinds of great influences out there in the ecosystem, like Terraform, for example, where they really split this notion of planning and applying. And so the first tool that actually popped out of KWT, this was actually some code that I was playing around with in KWT, and it got extracted out as its own project, was Cap, this little bit over here, this box. And, the principles behind Cap were really about how do you actually provide that confidence to a user who's using it to converge the system. And you can hopefully see that level of you can hopefully gain that extra confidence by actually being presented with a set of steps that will happen to your cluster. Right now, there's all kinds of other innovations that went into Cap as I was deploying various types of workloads, and obviously the tool continues to be improved on daily basis by a much larger team than just me. But there's definitely some interesting annoyances, one might say, that Cap tries to hide from the user that you may see, for example, with kubectl, or you may see with some of the other tools that may even kind of hit some of the limitations that Kubernetes provides, right? Maybe a tiny little example to make this concrete might be some resources might be immutable, right? Or maybe a field within the resource is immutable, right? And so that becomes much harder to automate without any kind of manual intervention if you don't have a certain level of configuration at your fingertips so that your tool can do this for you, right? So anyway, so Cap kind of popped out of there. And so once Cap popped out of this tool and became kind of its own thing, I was really, just exploring and researching this other space, like, okay, well, but how does one actually, develop and iterate on maybe something that you have deployed, that you want to deploy to a Kubernetes cluster, right? And, I'll just throw in here like YTT and Kbuild, for example, right? Both of these tools, they again try to focus on this idea that let's try to solve this problem, let's say, of configuration building, configuration mutation in a tool that only knows how to do that, right? So for example, YTT does not know anything about Kubernetes. It does not know anything about what's going to happen with the output that's coming in there. It just knows how to deal with data structures being maps, arrays, document sets, documents, etc. Right? And it just happens that I was also obviously in a Kubernetes ecosystem, so YAML is one of the kind of central points to it because everybody's working with YAML. Now, of course, influences of the design influences in YTT came again from previous experiences of bumping around the configuration gradient. On one side you have templating, and some folks are all into templating and it solves lots of their problems. And then of course on the other side you end up with kind of a patching mechanisms, right? Or overlaying tools, as some folks call it. And so there is that gradient, right? And you definitely find tools that either go into one direction or go into another direction. In my opinion, really the mix, the perfect tool is somewhere in the middle, 80-20 situation, where a lot of the stuff, for example, for your own authoring of configuration, you really want to be in the templating land, but then you still need that 20% power of overlays, for example, to customize, to shape that result. And maybe, of course, maybe you're not authoring your configuration, maybe you're actually picking up configuration from somewhere else, and then maybe your use case is more is more towards the overlaying versus templating, right? And combining those two sides within a single tool, within a single language, within a single set of primitives, within a tool that allows you to do this kind of a hermetic execution, really was a, in my opinion, kind of a hit the sweet spot to be a generic enough tool where you can actually use it for all kinds of purposes, powerful enough where, again, you're able to deal with these different types of workflows and use cases and different types of kind of organizational complexity. But yet at the same time, it's not a, it's not maybe it doesn't push you towards maybe a very opinionated way of doing it, right? Because you can solve a lot of problems if you get to have all your stakeholders agree on a particular pattern, right? But if you are really working with all kinds of different configuration coming in from anywhere, you really need that flexibility. And so templating, overlaying, kind of bringing it together in one tool, allowing programmatic access to it, I think kind of hits that sweet spot. And of course, as I already mentioned for CAP, we're continuing to iterate on YTT, continuing to elevate some of the ideas there. Every week or so, when John and I, for example, have our chats, there's always some more futuristic things that we could be doing. It's not quite, it's not quite on concretely figured out, but there's cool ideas about static analysis around the configuration. How do we, maybe visualize the configuration better to understand how things are happening and whatnot. And so that was kind of how YTT got born. It's really this pain with the existing tools that either shift to one side of the gradient or shift to another side of the gradient and just don't quite give you what you want. Over here is actually K-Build turned out to be, in my opinion, that little thing that just kind of fell out as an semi-obvious thing, at least in the workflows that I tend to use. So we have CAP that's doing the converging. We have YTT that's doing, configuration mingling. If you just run this pipeline, right, on your local machine and, you get your stuff deployed, the ultimate question becomes, well, how do you actually build the image and throw the image into your YAML and whatnot? And of course, you can try to build something custom with some shell scripts and, YTT, maybe inserting image references and whatnot. But that just doesn't quite scale, because then you have to do this every single time for every single project, and it's just different. And so K-Build kind of comes in and says, you know what? We know that there's plenty of great tools to build images, Docker, build packs, Bazel, all kinds of tools, right? How do we actually take those tools and just easily integrate that into a flow that, you might have over here, right? And by the way, as an example here, because these tools are really just focusing on their own single kind of a purpose, right? This kind of workflows, right? The idea was always, we don't want to solve or we don't want to force users to change their entire workflows, right? We want to really help the user solve a problem that they have, that they're coming to us to say, hey, look, I got this problem to maybe deploy, or I got this problem to build images, or maybe it's something else, right? And so tool specifically designed to solve a particular problem, and then continue on with your rest of the flow that you may already have. Or, of course, you can, adopt some newer tools over time, and maybe you do end up using all the Carvel's tools together or something like that, right? So anyway, so kind of a K-Build came after that, and it just kind of solidified this thinking around, each one of these tools is really just passing in the information to the next tool, right? Within the Kubernetes ecosystem, we have that shared format for what is this set of resources, right? And so, the interface between these tools is all the same. And of course, there could be other ecosystem tools out there that, again, use the same interface. So kind of a plug and play there. And so yeah, so that was kind of just the basic kind of a thinking around like, okay, we got all these tools that kind of work together well, and they also work with other tools well. And so then, kind of a Carvel project started iterating into some of the other interesting problems that we have faced historically, right? So we have image package, for example. I kind of threw this picture in. Maybe it's a little bit funny looking picture that image package just comes before here. But what I'm trying to showcase here, right, is that maybe in your one type of workflow, right, you're really picking up this configuration from your Git repository, like you git cloned and you run the steps. But a lot of times you also want to capture your, workload in some kind of immutable way, right? And look at that. We actually have registries. They know how to hold content. I think I want to say image package, in my opinion, kind of came out at the right time where it hasn't kind of kicked in for all kinds of other users that, hey, it's actually a really interesting idea to store content in registries. And so I think image package kind of came at the right time and said, okay, well, you know what, let's actually store other types of content that you may use in in various other places, right? And so we have image package over here as an example being used to store Kubernetes configuration, right? And so of course, once you fetch that configuration, then you end up, maybe going through this flow. Maybe you end up, I don't know, storing your Helm chart inside the image package, inside the registry, maybe some other types of configuration. And maybe, some people talk about like storing their ML data inside image package images. So really kind of a flexible, again, image package doesn't know what it's storing. It just says, I'll store it for you and I'll grab it for you on the way out. Now, what actually becomes interesting specifically for the Kubernetes case, though, is that if you think of registry as a place where you store assets, right, there's clearly some relationships between these assets, right? And again, the registry official APIs at this time, and definitely at the time of the image package creation, they do not have this notion of how to actually describe some of this relationship. And so image package decided to kind of explore this area of like, what if we actually able to store the relationship as part of the metadata around the bundles, right? And actually use that metadata in some kind of useful ways, right? So this is a little picture of just showing like you have your bundle that's built by image package, and of course you have your content, but then you have all these images and whatever, right? That you reference, right? And so you can kind of build hierarchies and you can kind of build your software graph. And this, of course, becomes really handy if you actually need to move that graph maybe to a different registry. If you're trying to understand what is the graph of all the stuff that I'm deploying, right? You probably want to make sure that your production environment is not running some random images and whatnot, right? And so being able to kind of capture all that holistically via same mechanism that you use, for example, to store container images, being able to attach and really reference this just seem like powerful concepts that we should explore and kind of push forward, right? And of course, our own usage within VMware is very much all about that, right? We want to be able to take the software that we build locally within VMware and then bring that out to our users, right? And so this is a kind of a typical use case that image package could really be used for. All right, I'll jump to the next one over here real quick. And so, stepping back from the image package, we have those kind of a little pipeline that you might be running locally. You might be running somewhere in your CI, right? There's nothing wrong with running this exact same thing in your CI, right? The tools are designed to be run in any type of environment. But what if you actually run the same tools in your Kubernetes cluster, right? And so this is where idea of kapp-controller kind of came about, and it evolved with the same tools. It actually evolved by a lot of the feedback from from our users around like, hey, I want to do this, I want to do that. And so app-CR concept in kapp-controller really evolved rapidly just to get to this stage where you're able to flexibly combine these ideas of where to fetch the data from, how to template the data, and then, how do you actually deploy it, right? And so this concept, or this pipeline that you might be running in CI, you could also decide, hey, you know what, let me have a first-class API for that in Kubernetes cluster. And this is a little picture of kind of a, forget about the stop part, but AppCR really just focuses on this three pieces, right? Fetch, template, deploy, to represent an application, a workload running on your cluster, right? And so once we had that kind of idea around, like, okay, well, we have this AppCRs, right? How do you actually, take advantage of them? Well, you could obviously do GitOps on your cluster with your AppCRs, right? You can configure it to pull, maybe from Git, maybe from HTTP endpoint, maybe from, I don't know, image package bundle, from anywhere, right? And you can actually do all kinds of massaging of the Kubernetes configuration with YTT. Becomes, again, really powerful, because you can really take whatever somebody else, maybe an example might be, maybe somebody needed to change a bunch of stuff about Cert Manager installation, or maybe they wanted to change a bunch of stuff around how they deploy an application in production or the staging environment, right? And so kind of relying on the tools to do all that heavy lifting, and really kapp-controller staying, really just sitting there and delegating out all this work. It seemed to be a really good idea, right? And so we kept on exploring it, kept on adding the features to kind of support these different use cases. And actually, a bit later after that, kind of ideas came around. Well, okay, you have this AppCR, that's great. I can put an AppCR into some place, and then I can give it to somebody, and they can also, I guess, install the same type of content into their cluster, right? Well, the kind of annoying part about that, right, is that suddenly users who are taking this AppCR and maybe bringing it to their cluster, right, they're exposed to all these details that they may not care about, right? And so this was kind of the idea around packaging, right, is that really we just want to be able to assign some name and a version, right? And let the user reference that, and not really worry about the underlying implementation of where the thing is coming from, how it's configured, and maybe how it's deployed, right? And so that was the kind of idea of, okay, well, we have this building block AppCR. Let's build a package install on top of that, right? We want all that functionality for free, right? It's the same kind of model as the pod and a deployment, right? The deployment really just delegates a lot of the heavy lifting to the pod. So same exact thinking here. Package install delegates a lot of that heavy lifting to AppCR. And of course, somehow you have to build the AppCR, right? You have to create it in the cluster, right? What I mean is the controller needs to create in the cluster. And so the package CR idea is really just, hey, attach a bunch of metadata to an AppCR template, and that's what's going to get created. Now, again, once you get to this layer, suddenly this, again, naturally starts falling out as a next step. Okay, well, I have all this bunch of package CRs. How do I actually give it to the users, right? And so again, the next idea was, okay, well, we'll just put them in a package repository, whatever that may be. And so in this picture, I guess it says package repository could be an OCI bundle, and that's, for example, my favorite option, but there's no reason why that couldn't be inside a Git repository or some other place. And so, yeah, so this was kind of the general transition, or not transition, but evolution of these tools and of this kind of of these concepts, right? The principles that we're still, very much sticking to is that ideally, the tools are single purpose. They know how to do something well, and they delegate the other type of functionality that you may find to different tools, right? And there's actually an example of secretgen versus kapp-controller that came up in a earlier section. Was secretgen is all about dealing with secrets, right? Generating some secrets, or maybe actually one of the features there is also sharing the secrets between the namespaces, right? So kapp-controller doesn't really have any special notion of a secret, but secretgen is all about secrets. And so there's all kinds of an interesting kind of a division of labor you can imagine between these two controllers. So anyway, I'll just say, okay, so this was all kind of a where we are, how we got here. You know, the principles I think that we've tried to abide by within the tools and just within the APIs and concepts, right? We believe they are maybe universal, or maybe universal is actually maybe a bad word, but they are solid enough to keep on building additional types of maybe tools or additional types of experiences on top. And so as we proceed into the future, right, we're obviously looking for how do we, for example, polish these workflows in particular way, right? How do we, for example, solve some of the problems that maybe local development use cases really require to be solved, right? Or how do we, for example, focus on particular packaging related issues, like, for example, you know, if you end up having 10,000 packages, right? How do we evolve the system in such a way that that's really not a problem, right? And so I think the foundations that we've kind of laid out and some of the kind of rules we've set up where certain things, like where certain responsibilities within the software goes, seems to keep on, I don't know, I think, at least in my opinion, work out in our favor. But yeah, I think, you know, maybe at a more strategic, larger, kind of a big picture points, we absolutely want our greater, you know, Kubernetes ecosystem to embrace some of these APIs and tools as you know, tools that anybody can expect to use, right? So, for example, a lot of the open source projects, we would love if they would be providing packages for their software from their repositories, and we're obviously working towards making the package authoring experience easier and more just accessible to everybody. We also hope that, even aside from the packaging side of it, a lot of these tools are really used in this different context for the in-house application development, right? How do you actually, you know, configure the multi-cluster systems, multi-environment systems, right? So the tools and the features are there. Now our next steps are really try to produce guides, content around how do we actually make this make adopting of these tools maybe as easy as one would hope, right? And that obviously is a lot of work in itself. So yeah, I'll just maybe pause. I know I've been rambling for a long time, maybe a little bit all over the place. Any I don't know, any comments from anybody or anything?
Totally. Just, I'm really glad that you did this presentation, Dmitry. I think like showing kind of where the project comes from. I think the really special thing about the Carvel project is that like you get this really nice like individual factoring of subproblems. It's like so good for users. It doesn't force opinions on people. And like we've ended up with these very sharp, targeted like tools for problems that are like so common for the practitioner of container native workloads. And I'm just like, I'm very thankful like that, like we're finding maturity, that we're finding like stability, that we're picking up like a community of folks who are really like passionate about like kind of this next generation of like really healthy tools. And I think that that's what makes Carvel really special.
I agree.
Yeah, we definitely I don't know if you've given like this like talk like elsewhere, but definitely I would be happy to like signal boost this message. You know, we should like propose this presentation like 2 places and like have people talk about it, because like showing where these things come from. It's unique, honestly. Like I think a lot of times when you like find popular solutions in the cloud native space right now, it's like the ecosystem is so early, and like the problems that people are running into are so broad that many of the tools that solve these problems, they're either only like a single project solving a single sub problem, or you have very opinionated tool sets, right? Like if you look at Helm, which is very early on, right? Before CRDs were even a thing, before formal API extensions like were really a thing, Helm was already coming out of Deis, which is no longer a thing. It's part of Microsoft now, right? And the Helm has turned into this massive community, but it's a very monolithic and opinionated tool set. And some of those opinions, we've kind of agreed as a community, like, oh, there's a huge trade-off. Like it kind of, like some parts are really good and some parts kind of suck. And you can't get away from the parts that kind of suck because the tool is built as a monolithic opinion. Similarly, like I could point out like the Argo project, right? Like massive like community adoption. But it's one opinion that the community is only just starting to factor out into individual pieces. And that comes from like Intuit's developer platform. And so to get something like Carvel in the ecosystem where it's producing like well-factored individual tools that people can just say, oh, I only want this piece, right? Or I only want that part. Like now we're getting away from specific opinions, or even getting away from focusing hyper focusing on Kubernetes specifically, right? Like you can use K-build and like Docker Swarm. And that's just, I think, so special. Like that's unique. You don't see that elsewhere in the ecosystem. So we should be talking about this more. You know, we should definitely keep sharing the message.
Yeah, I think there is definitely it's an opportunity to capitalize on this decouplement of these different problems and different tools. Yeah. But it's also a messaging challenge on its own, right? The type of messaging that one may find easier to digest for a monolithic project is potentially doesn't just apply easily for a project that's composed of the smaller units and whatnot. But that's I don't know, maybe that's also true for just composed or decomposed software as well.
We're learning some of these things even in the Flux project, which has been running for a similar amount of time. And like the original Flux v1 was a monolithic solution with some pretty strong opinions, but it was extensible in some really hacky ways. And like as the user base grew, we like outgrew that design and like needed to factor things into individual components. And now Flux v2 is a healthier, more individual component extensible ecosystem. It's one of the reasons why, as like VMware, we have other projects that are actually gluing like Flux and Carvel stuff together, is because they kind of both can compose since they're so individual or like so well factored. But still with Flux, like it has a completely different presentation, and there's still like, Flux Bootstrap, Flux Install is still like pull all of these components together and give somebody, a kind of a default starting point. And that's sort of different and kind of speaks to that challenge that you're just talking about, where it's like, how do you help people get started when all of these things can solve so many different individual problems? Yeah, again, thank you for presenting. I learned a lot.
Thanks for that, Dmitry, and thankfully for your comments. We are a little past time. I know we have one thing left on the discussion topics, or two things left on the discussion topics. We will probably have